Hello, everybody. Welcome to another edition of Biology in the Basement, special edition, Base in Your Face still. Shout out to Mr. Bonesy for helping us out. We've been finally getting to where we are going to talk about bones and the skeletal system today. So thank you, Bones. We're going to use you tomorrow in kind of a little lab activity where we'll get up close and personal with Mr. Bones and go through all of his bones. But today we're just going to get through the meat and potatoes and talk about the skeletal system as well as an overlooked organ that is pretty amazing, which is bone itself. So we will cover both of those things, and let's get started. Here's your fact of the day. This might make you feel better. I'm wearing my Grateful Dead shirt since it's got a picture of Bonesy right on the front of it. You know, they were well known for using skeletons in their advertising. Anyways, this shirt is from a concert in 1977, May 8th, regarded as one of the Grateful Dead's best shows. Happened to take place not 19 miles down the road. But May 8th was the date, and I've read a book about this concert from some attendees and, you know, people from the college. And the interesting thing is that while they were leaving the concert, which would technically have been around May 8th, May 9th, as they were leaving the concert, it snowed. So if it makes you feel any better about the fact that it snowed like yesterday, know that on May 8th in 1977 in Ithaca, it also snowed. So I don't know if that's supposed to make you feel better or worse that we may still see snow, but that's a weird thing to happen in May. So just letting you know there, in solidarity with old Bonesy here. You know, me being a product of 1977, just like this concert, I like to keep an eye on those things. So let's talk about the skeletal system. Now, we just got done talking about the muscular system, and if we're talking about skeletal muscle are nothing without actual bones. The bones are the levers that help the muscles attain the movement that they are trying to accomplish, specifically in your arms and in your legs. But of course, as you can see there, and in other pictures, those aren't the only ones. So let's talk about all the functions of the skeletal system, because there are more than you may have thought of. Of course, we need our bones to act as levers for movement, but as you can see now that Bonesy is naked, you can see things like his rib cage, and underneath there, he's got a cranium. What are those for? Protecting internal organs. That's another very important job of the skeletal system. So it's got to do movement. It has to protect your internal organs. We also, of course, have talked from the immune system. I don't want to give you PTSD from too much immune system. That the inside of your bones are what create white blood cells as well as red blood cells. And another interesting factoid too, of course, as its responsibility not so much in our bodies, but it's where we store our calcium and other minerals like magnesium. And if we were an egg-laying animal, whether a platypus, bird, or reptile, we could actually draw the calcium from our own bones from storage to create an egg. So, we've got all of those functions there. So let's move on. Here's where I talk about how awesome your bones are. Now, think about this. Whether you're predator or prey, you got to be super fast. But you also have to be super strong. So, your bones need to be durable to handle lots of force, but they also need to be super light so that they can move quickly. I always imagine that if Wolverine was real and all of his bones were dipped in metal, he would weigh like 1,000 pounds, right? And he would have to have super strong muscles to carry that metal skeleton around, right? And our bones, of course, are designed to do both, right? They are super tough, they are super light, as well as they produce white and red blood cells in the center of most of what are called the long bones of your body. Okay, now, how do they do that? Well, they have to have both things. They have to have a way to be tough and a way to be lightweight. So they have what is called compact bone, that is on the outside, and then they have spongy bone, which is on the inside. The ends of your bones are not just a solid ball, they are spongy. Usually this is where I would bust out all of my cow bones and things like that and show you spongy bone. I would bring the real skeleton out and show you, and half of you would be grossed out to see, but it really is like a sponge inside the ends of most of your bones. And so that's what is the way that we achieve this lightweight as well as toughness. And that toughness comes from what's called perosteum, or periosteum. I'm not sure how to pronounce this one, to be honest with you. Periosteum is this tough layer of the outside. So the outside of your bone is where it is super durable and super strong. The rest of it on the inside is soft tissue, whether it is the marrow or whether it is the spongier parts. It's softer. The outer covering is very strong, but the inside is relatively soft or hollow almost, not as much like birds. The term in the middle here, the Haversian canal, is more of a logistical question. If you're thinking to yourself, well, if the inside of my bones are making products, right? They're making red and white blood cells. How do we get the raw materials into this quote-unquote blood cell factory in, and how do we get these blood cells that we produce out? If your bones are supposed to be super tough and strong, but have a factory essentially on the inside, how do we get the stuff in and out? Well, we actually have a network of tubes and canals that run in and out of bones. So there are blood vessels that are going in and out of your bones through small pores. And so I usually direct you to these spots right here where it looks like they're ending. They don't stop at these points. This is where they go in, right? And they enter into, and you can see there is a whole network of blood vessels running through the inside of your bones. So when your blood cells need the raw materials, they can be delivered, and when they make their product, they can be exported, technically, if we want to look at it in terms of a factory, because that's how I see your marrow. And, of course, that's what gave us our big brains, as we saw, I think, in one of those last videos, right? We evolved to be very smart because we were able to use tools and extract this marrow full of protein, and that led to larger brain growth, which made us, the smartest apes around. So here are some of the blood cells that come out of here. If you watched the video, you probably saw how there's all these different blood cells that come out of the marrow. Then they go through these different training camps, and some of the cells just die in the process, and some of them just stay as certain cells. So it's a really complex process, so we won't go into it, but they make a lot of cool cells. Another one to talk about is cartilage. What the heck is it? Now that we're talking about this structure of our body and how we move and how we function, right? How do we explain cartilage? The way that we explain cartilage is technically it's what's called a connective tissue. I will explain connective tissue in a minute. But connective tissue is not bone. It is a tissue, just like a connective tissue, I should say, that connects things together, like your tendons and ligaments, which we'll talk about. So cartilage is this softer connective tissue that supports like bone but has flex to it. I always gross people out when I say, imagine if you had to play lacrosse or put your football helmet on and your ears weren't made of cartilage. You just snap your ears right off, right? It's a good thing that we have this kind of tissue where we need support, but not full rigid bone. Other places where I always like to point out is the trachea is lined with cartilage, just kind of like your vacuum hose, so it doesn't get squished. You know, when you just go like this, you'd suffocate, right? So you have these nice rings of cartilage that are keeping your trachea breathing air all the time. Okay. Other spots, as we'll show, right? I can even show on Bonesy, the ends of your ribs are actually cartilage, so that they can expand and take in air. The discs of your back are also a form of cartilage. So those are some other examples. Thank you, Bonesy. I hope I didn't just get me tooed. All right, so we've got to talk about joints as well. This is a place where just bones attach to another. I will give a lot of examples when I get up close and personal with Bonesy tomorrow, and that is where we have the elbows here as hinge joints. We have the shoulder here as a ball and socket joint. We have saddle joints found in your wrists, cranial joints, obviously, which you would be surprised, sorry, Bonesy. But Bonesy has what are called sutures in his head that act as now fixed joints, but they were movable joints as, of course, your head started to take shape. So then they became permanent, immovable joints, as they're called. The rest of them are freely movable pivot joints included. Did I cover them all? It's hard to talk with the information behind my head. Anybody want to donate to get Andrego a teleprompter? That would be awesome. 2 parts of the skeleton. I've got a great chair to actually do this example, right, where you have your axial skeleton. Bonesy's axial skeleton, right, is his chest cavity, which includes his digestive, reproductive organs, as well as his respiratory, circulatory system, and then his cranial nervous system and your spine, right? That is kind of like your y-axis. But then you've got your appendicular, right, your appendages, right, where these guys are separate from your axis. I know I look really silly right now. I hope you're laughing at me. Because this is just how this works. You have appendages and you have an axis. Of course, ours is different than other mammals, as most of theirs is a horizontal axis, where ours is a vertical one. So that's what that's called. Like I said, we will look at the all the bones of the body. I used to get the kids extra credit for being able to identify 15 bones off right in the middle of class before we would have a bone quiz. But we won't be doing any of that. But I will walk you through all the bones of the body. I would like you to know them by their proper names and just other interesting information. So we'll do a short video about that as well. All right, so last thing, connective tissue. You've got two other types besides cartilage. The first one are your tendons. They connect muscle to bone, right? A muscle has to cross at least one joint. And so for your bicep to actually pull this arm towards you, you need to have a tendon at the end of this muscle that's attached over here to this bone, so that when this muscle contracts, it has something that it's pulling on to contract that bone back to the body, right? That's what contraction is. And so those are the connective tissue that connect muscle to your bone so that the levers can move. But you've also got ligaments. Ligaments are what connect bone to bone, right? Your bones need to be connected to each other. Your skin can't just hold everything together. That'd be silly, right? So these bones must be connected to themselves besides just to the muscles, and we call those ligaments. These are the gristly things that you eat when you have chicken. The old agriculture teacher used to bring in giant chicken parts and, have the kids dissect chicken and, go over tendons and things like that with them. Anyways, we have lots of athletes in the group, and we had a huge debate, I think it was last year or the year before, about which one's the ACL and which one's the meniscus. And so we put the newest diagram I could find from the internet last year, I believe, talking about what all this is, right? First, the pink stuff is cartilage. We also have cartilage in between our joints to protect your bones from wearing out. You don't want bones just grinding on bones. You need some type of cartilage in there to protect them from wearing down. So the next ones we're looking at, right, are the actual ligaments. There's no muscles here, so we don't have any tendons. So, of course, all these L's are or CLs, I should say, are connective ligaments. So your ACL, the one that gets torn a lot, is inside the knee, underneath your patella, your kneecap, and your meniscus is the one that is on the inside of the knee, right? When you tear your ACL, that's kind of like underneath your patella, and your meniscus is the one that you tear this way, because your leg is not meant to bend in this direction, only in this direction. So that's why that diagram is up there. And if you're athletic trainer or you're interested in any of the sports or stuff like that, hopefully that makes sense when you hear about torn ACLs and meniscus and what's the difference. So we did that just because it got into an ugly debate, as you guys know. Okay, the next thing we're going to talk about is skin, so that means I'm done. Let me give you your assignment. Now we're back to the skeletal system, which is H175 to H177. So that is Mr. Andreyko signing off from Biology in the Basement.